Hello friends, this video on Chemical Kinetics part 8 is brought to you by examfear.com. No more fear from exam. Let's understand the new term called specific rate constant for a reaction. See, this K is what? For this reaction, A plus B is C plus D. The rate equation is K into A to the power X, B to the power Y, and X and Y are experimental value, and this K is my rate constant. This is what we have seen till now. Specific rate constant is nothing but that is the rate constant when the concentration of each reactant is 1 mole per liter. So in that case, my rate constant becomes specific rate constant. Correct? So if you see, the rate constant which we have studied till now is the characteristic for a given reaction. This will have a fixed value for a given reaction, right? It has different values for different type of reaction. For each reaction it will have a different fixed value, and it is independent of concentration, but depends on temperature. And for this, we'll see Arrhenius equation. We'll see that this K depends on temperature, and large value of K implies faster reaction. Large value of K implies faster reaction. So K is what? Rate constant. Specific rate constant is what? It's nothing but the rate constant when the concentration of each reactant is 1 mole per liter. Nothing great. And please note, this rate constant is independent of concentration, but it depends on temperature. For a given reaction, for example, C plus O2 is equal to CO2, where I've defined the concentration of carbon, oxygen and carbon dioxide, right? In that case, this will be fixed. The value of K will be fixed. Now let's see the unit of rate constant. That is nothing but K. For this kind of reaction, A plus B is equal to C plus D. We have seen that rate is nothing but K into E to the power X, B to the power Y, and where X and Y are my experimental value, and X plus Y is nothing but order of reaction. Now, rate of a reaction is always in, we have seen, moles per liter second, right? Both liter and second is in denominator. Let me write this line this way: moles per liter per second. Correct? See, concentration of A will be in what? Moles per liter, and concentration of B will also be in moles per liter. So this becomes X plus Y, because both are same. Moles per liter to the power X into moles per liter to the power Y is nothing but moles per liter to the power X plus Y, and here is K. Correct? So if you see, K is nothing but, if I want to write the units of K, K is nothing but my rate by E to the power X, B to the power Y. Let me write the unit. Rate is nothing but moles per liter per second, and this is moles per liter to the power X plus Y. That is nothing but order of reaction. Correct? Because both has same unit, A and B, moles per liter. Now, if you talk about, let me put the values here. This is order, and this is unit. If you talk about zero order reaction, then you put this is 0. So the unit of K will become moles per liter per second. Correct? For zero order reaction, unit will be what? Moles per liter per second, and this becomes moles per liter to the power 0. This becomes 1. So unit will become moles per liter per second. Correct? If we talk about first order now, this becomes 1. So in this case, unit will become what? Moles per liter per second, this per second, divide by moles per liter to the power 1. So moles cancel, per liter cancel, you get order as per second. Please note, very important, most of the reaction is first order reaction, and for this unit is per second. For second order reaction, let's do the same thing. Let's do somewhere here. It will be what? The rate unit will be same, that is moles per liter per second. The denominator will change, that will become moles per liter to the power 2. Correct? Moles per liter to the power order of reaction, that is 2. So if you solve this, what you get is liter per mole per second. See, second nobody is touching. Moles per liter, and this is moles per liter square. So 1 gets cancelled and 1 becomes, it is nothing but 1 by moles per liter. That is nothing but liter per moles, and per second is there. Similarly, for third order, if you want, you can find it actually. This becomes liter square moles inverse per square second inverse. But generally we'll be using these two. So the point to note here is the unit of K, the rate constant, is different for different order of reaction. For 0th order, the unit is different. First order, unit is different. Unit of K. Correct? This guy. So here we have to find the rate reaction order. The rate constant is given, and we know that the rate constant has different units for different order. Just by looking at the rate constant, we can tell that this is order 2, this is order 1. We just solve it. Correct? If you don't remember, this is second order, this is first order. If you don't remember, what you can do is, you can just say rate as K into A to the power, let's suppose order. Correct? Reactant to the power order, concentration. So rate we know is always moles per liter per second is equal to K is given. K is what? First is liter per mole per second, and reactant is always in moles per liter to the power n, let's suppose n is the order. Correct? So let's put this side here. So this becomes liter per moles per second. I am putting everything this side. Per second cancel. So what you get here is moles per liter to the power 2, and this side you get moles per liter to the power n. So compare these two equations, you get n is nothing but 2. You can say it's second order equation. Correct? If you want, you can do for the second part also same way. So rate is nothing but K. Rate is nothing but K, and reactant to the power order of equation. Rate is always in moles per liter per second. K is given per second. Reactant is always in moles per liter to the power n. Let's suppose n is my order of reaction. So you put second this side, second number second cancel. You get this side, if you see, moles per liter is equal to moles per liter to the power n. You compare this with this equation, n is nothing but 1. So it's first order reaction. Correct? So here from the rate expression for the following reaction, we have to determine the order of reaction and dimensions of their rate constant. See, the rate expression is given. This is my rate expression, and this is also my rate expression. We have to find order. Order is nothing but sum of this coefficient. Here we have 2 only. So this is my second order equation. This is my 1 and this is 1 to the power 1. So 1 plus 1 again is 2. So this is also my second order equation. Both are my second order equation. That is done. The next is find the dimension of the rate constant. We know that for the second order equation, unit of K is nothing but liter per mole per second. If you want, we can actually find it. See, for this example, rate is equal to K into NO2 to the power 2. So K is nothing but rate by NO2 concentration to the power 2. The rate unit is what? Moles per liter per second. NO2 is what? Moles per liter. But this whole thing is square. So if you solve this, you get nothing but liter per mole per second. And that is the unit for K. In the next example also, if you see, that is also second order equation. So unit will be same. So you can just directly say that it should be same unit, or if you want, you can actually solve it. You'll get the same value of the unit for K. Please note, the unit of rate is always moles per liter per second. The unit of concentration is always moles per liter. It is the K which. Let's take another example. We have to find the rate expression for this. We have been given the rate expression for these equations. You have to find the order and dimensions of K. See, order is pretty easy. This is 3 by 2 and this is 1. Correct? Because order is nothing but sum of all the coefficients here in the rate expression. The next question is, the next thing I have to find is the dimension of rate constant. So I know if for, let's take this is equation 1. So from equation 1 I can say K is nothing but rate by CH3CHO to the power 3 by 2. Let's put unit of this. The rate we know is always moles per liter per second, and this is what? Moles per liter to the power 3 by 2. So if you solve that, this is nothing but liter to the power 1 by 2 moles to the power minus 1 by 2 and per second. That is what you get. And for this, since it is order 1, we know that K will be per second. You can actually solve it. We have done this in so many questions. Unit of K will be per second. The second scenario where the order of reaction is 1.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.